Well, good evening, students. Just give me a moment. Let me share my screen. Okay, I have a few problems in electricity. So let me just do these problems so that this will be useful even for your test. Okay. I have to hold it somewhere. Just a moment. Okay, I don't know where to hold this. Anyway, let us begin. I hope it is recorded. Yeah, it's recorded. Okay, fine. So the graph shows a variation of current with potential difference for a filament lamp. Okay, so this is your I versus V graph. And here you observe that what is the resistance of the filament when the PD is 6 volt. What is the resistance when PD is 6 volt? What you do is, this is your potential difference V. Draw a vertical line here. It intersects the curve here. And corresponding to it, find out what is the current. So this is 10, this is 8. This is somewhere lying in between here, midway. So this should be 9. Okay, so as a result of it, we know that current I is nothing but V by R, which means what is he asking here? He's asking you to find out the resistance. So R is equal to V by I, which should be equal to what? 6 volt divided by, this is 9, and this current is in milliamperes, 9 milliamperes, which should be equal to 2/3 into 10 cube ohms. So what is 2/3? 0.67. You can try it out with your calculators. 0.667 or maybe 0.67 into 10 cube, which should be nearly 670 ohms. So this is your right answer. Then an electron is accelerated to a potential difference of 2.5 volt, 2.5 megavolt. What is the potential difference? Now what is given here? Delta V is given. Kinetic energy is being asked. So potential difference is given. Note the phrase electron. Electron is given. When I say electron is given, that means the charge on an electron is E, and potential difference is given. You need to find out the kinetic energy. So kinetic energy is equal to, kinetic energy is nothing but energy. We all know kinetic energy should be half mv square. You might be looking at where is m and where is v. That need not be given over here because this is given. So we know that kinetic energy is nothing but work done, which should now be equal to Q times delta V. Now what is Q? Q is nothing but E. And what is delta V? 2.5 megawatt. Now let us substitute all the values. Value of E from your data booklet, you can take it 10 power minus 19 into 2.5 into 10 to the power of 6. So let us calculate what is this value. Just a moment. It should be 1.6 into 2.5 is nearly 4. Answer is 4 into 10 to the power of minus 19 plus 6. It should be 4 into 10 to the power of minus 19 plus 6 should be minus 13 joules. Now let us look at which of these would be helpful. 4 into 10 power minus 13 joules. Okay, I can also write this as equal to 0.4 into 10 to the power of minus 2 joules, which is 0.4 picojoules. So this is the one. C. Then a cell is connected in series with a resistor. A cell is connected in series with a resistor. Okay. And supplies a current of 4 amperes for 500 seconds. So current is given, time is given. Now if current and time are given, what can you find? You can find out the value of Q, which is nothing but Q by delta T is equal to I, or Q is equal to I times delta T, which means what? You can get this as 4 into 500, which is 2000 coulombs of charge. Okay. During this time, 1.5 kilojoules of energy is dissipated in the cell. Some amount of energy is dissipated here, and some amount of energy is dissipated in the resistor, in the cell and as well as the resistor. It means close this. Now, what is he asking? What is the EMF of the cell? Okay. Some energy is lost here, some energy is lost here. Why is it being lost? Let me call this as E1. let me call this E2. Okay, why is the energy lost? Because maybe this will have some inherent resistance. This might also have some inherent resistance. As a result of it, energy is lost. Okay, so therefore, total energy loss E is equal to E1 plus E2, which is equal to how much? 1.5 plus 2.5. 1.5 plus 2.5, which should be around 4 kilojoules. This is the amount of energy lost. Why is this lost? Because an electron or the charges are doing work against the direction of electric field, and as a result of which energy is lost. Okay. Now, what is given here? Q is given. Q is given. Now, when I say energy, energy is related to EMF by the formula Q times delta V is equal to work done. So what you do is Q, what is Q? 2000. 2000 is equal to 2000 multiplied by delta V is equal to what is work done here? Work done is energy dissipated, which should be 4000. Solve it. Delta V should be equal to 2 volts. So the answer is done. Next one. Diagram shows two equal and opposite charges that are fixed in place. You will have minus Q, you have minus Q, plus Q here. Okay, minus Q plus Q. At which point is the net electric field directed to the right? So you want the electric field to be directed like this. So the easiest way is, if I keep it here, what will happen? Net electric field will be like this. Then if I keep it at Y, at point Y, this is repelled away like this, getting attracted like this. So definitely net electric field is in this direction. So therefore, definitely it is not Y. It is not Y. It is not Y. Let me encircle this. If I keep it X, now what will happen? This plus Q will throw this charge here. But while this minus Q will now make it to move like this over here, right? So here, the attraction is much larger. And here, the repulsion is much smaller because you see, it's farther away. So the net force would always be attraction towards minus Q. Now let us take up this point. We already seen X, Y. Now we are seeing Z over here. In Z. So what is the net force here? Net force is in this direction. When I say it's along X. See, but here you see X and Y, Z and Y, X and Z, X and X, Y and Z. So definitely this is incorrect. Z and Y, because it doesn't have an X. X, Y and Z is also incorrect because along Y it is in this direction, opposite direction. So one amongst them should be right. Now, if you do not know how to investigate this, you can still say X and Y. X and Y definitely is incorrect, right? And the only option here is Z. If you want to make a confirmation, what you can do is you can just say at this point, this charge throws it away. It means the vector is like this. And this charge is attracting it like this. Net force is always in this direction. So thus you can say that X and Z are the only option. Then, next one. The wire has a cross-sectional area. The cross-sectional area at Y is double that of area at A. So if this area is A, this area should be 2A. At X, the current in the wire is X, and the electron's drift speed is V. What is the current and electron drift speed at point Y? So what should you do? So you should just write I is equal to NEA into VD. Okay. Now, what is being given? Drift velocity is given, current is given. Now the question is, when the current is flowing like this, when it comes to the different diameter, will the current change? Current will not change. Because what is current? Current is nothing but total charge by total time taken, which should remain a constant. If suppose, if there is a current dissipator, if the current branches out, then the current can reduce. If there is a battery, external battery, which is connecting these two, okay, then the current can increase here. Else, current cannot increase. Now let us see a current in the wire. N will not increase. E will not increase. A. Now A should definitely change. And VD can also change. Okay. Now since current is constant, now I should say the current at this point is I1, current at this point is I2, and I1 should be equal to I2. Now as a result of this, these two are incorrect. You should have one amongst them as the correct one. So if I do that, then I'll have NEA1 V1 is equal to NEA2 V2. This NE goes away, this NE goes away. Now what is A1? A. And what is V1? V1, what is V1 is given? At X is V, at V is equal to EA2, which is 2A. And what is V2? V2 is just V2. So this EIA goes away. So V2 should be equal to V by 2. V by 2. So this is the right answer. This is incorrect. Next. A circuit consists of a cell of electromotive force of 9 volt and internal resistance 1 ohm. 9 volt. What is it? It's given here. Internal resistance, which means the battery also has a resistance. That's called as internal resistance. And the resistance of 4 ohm. The ammeter is ideal. Okay. XY is a connecting wire. XY is a connecting wire. What is the reading on the ammeter? What is the reading on the ammeter? Okay. Now what will happen? The current always takes up the easy path. So it comes all the way around here. It comes here. And here it says XY is a connecting wire, which means what? You have shortened it. Shortened means what? This is a resistance-less wire. If this is a resistance-less wire, then what will happen? All the current will go like this. Even if it is 4 ohms, no current will pass here. Every current will pass over here. Okay. So now he is asking you what is the current. So the total resistance here is 1 ohm, and the total voltage is 9 volt. So 9 divided by 1, okay, which is 9 volt divided by 1 ohm is your current. You should not take this one here because no current passes like this. Wherever there is a resistance, there is no other way, then it will pass through it. But if there is a resistance-less wire, it will always pass in this direction. It won't pass here. Okay, so therefore 9 by 1, which is equal to 9 ampere. So answer is C. Most of them have got confused with this question, and they do what they do is they consider the equivalent resistance between these two and think that maybe this is 2 ohms. Then divide 9 by 2, okay, and then you get something like 4.5 amperes. Some of them they divide by 4, okay, you get an answer and so on. Okay, all those are incorrect. This is right. Each electrons, each with the speed E, moves with the speed V along a metallic wire. The current in the wire is I. Plane P is perpendicular to the wire. How many electrons pass through the point P in each second? So what is being given? E is given, speed V is given, current I is given. So we know that I is equal to NEA into V. Plane P is perpendicular to the wire. How many electrons pass through plane P in each second? How many of them are passing through this? What is being asked once again? How many electrons? Which means it is a number of electrons. Okay, in each second, N by T. This is what is being asked. Now towards it. Now once again, is a length given? No, length is not given. Okay, so you just need to find out the value of N by T. Now how do we do this? So one way, so okay, the way now is we know that I is equal to N E divided by T. Now what is being asked? N by T is being asked. You need not do this one here. You can just say N by T is equal to I by E. So this should be your answer. Now let us look at that also. Where is I by E here? I by E is somewhere over here. First, let us check whether we are doing it rightly. Now, there's a T here. Yes, it's right. I by E. Okay, next. Positive charge is uniformly distributed on a circular plastic rod. What is the direction of the electric field? So you have positive charge everywhere here. Now what will happen? The positive charges at point S, okay, this positive charge will have an electric field in this direction. This will have an electric field in this direction. This will have an electric field in this direction. This will have an electric field like this. This will have an electric field like this. I have just thought that these are the only 5 charges. Okay, there could be a number of charges, but I am doing it like this. Okay, so now whenever I put more number of charges, once again I can draw this hypotenuse. Now what will happen? This charge, okay, you split this electric field due to this charge into 2 components. One along this direction, the other along this direction. Similarly, take up the analogous charge here. This charge electric field will be split like this, and it will also be split like this. So what is happening? The electric field on the upper part is cancelled by the lower part. Repeating the same analysis, every upper component is balanced by the lower component. That's what gets added up, only the horizontal components. So the net electric field is in this direction. So the answer is B. Answer is B. Then a minus 5 microcoulomb and a plus 10 microcoulomb are at a fixed distance apart. Okay. Where can the electric field be zero? Okay. We need to find out where is the electric field zero. If I keep it here, definitely it is not zero. Why it is not zero? Because 10 microcoulomb is now pushing the particle like this. It has an electric field like this. -5 is attracting it like this. So this position is not zero. Position 2 is wrong, which means position 2 is wrong. Positions 1, 2, and 3 is also wrong. So you are left out only with position 1 and position 3. Only one of them should be right. Now, if I keep it here, then what can happen? This can repel the charge like this, while this will be able to attract it like this. So there could be a possibility. Let us look at that also. Then, now how do I decide whether it's a possibility or not? That's the first question we should ask. Now towards it, what does it say? At a fixed distance, what can be the electric field? Where can the electric field be? Zero. Okay. So towards it. Now you see, this charge is 10 microcoulomb. And you observe that they're all kept at equidistance over here. If this is called as X, this should also be, no, this is called as X. Okay, let me call this as X over here. So as a result of this, now what can happen here? Now you can have K into 10 by X square minus, now this difference between these two. I think these points are equidistant. Just a moment.